In this video, we are going to talk about the first type of trigonometric integral. The first type is sine raised to the n power times cosine raised to the nth power. So this video is only a cookbook recipe. We are not going to do any example in this video. When it comes to trigonometric integral, you have a big cookbook recipe to take. This is your first type. We still have type 2 and type 3. So in first type can be divided by into three cases: case 1, case 2, and case 3. And then when I was a student, so the way I do this is I wrote the entire piece of notes. Okay, either you take it from me or you take it from the book, and then I give myself a problem, and then I check the power of the sine and cosine to see if the problem fits to case 1, case 2, case 3. If you are allowed to use notes for exams, you have to put this on your notes. If you are not allowed to carry any notes to exam, then unfortunately, you have to memorize all the cookbook recipes. All right, so case 1, again, let's take a look at the integral first. We have sine raised to the nth power times cosine raised to the nth power, m and n. And then case 1 is when the power of cosine, the power of cosine is odd. So that means the n is odd. So how do you make an odd power? You have 2 times k. So 2 times any number, you double up a number, you add 1 to it. So that is always odd. So when the power of cosine is odd, you have to factor out 1 cosine. And then you have to use the fundamental identity, cosine square equals to 1 minus sine square. So the problem is usually like this. They give you a sine raised to a big power times cosine raised to an odd power dx. So first thing first, look at the second line of the integral. You have to factor out a cosine first. I already underlined that in red for you. And then the rest, you have cosine square and then parenthesis k. How do you get this thing? So let me just do this in another color. So you have in the second line of integral, you have a power of second power raised to the k, right? So when you do that, you have 2 times k, and then you still have another power on the cosine. So that means you add another power to it. That is equals to 2k plus 1. So you start at 2k plus 1. You take the 1 out, so now you just factor out a cosine, and then the leftover, you have a 2k. So inside the parenthesis, you use 2, and then for the entire term, you raise that to the kth power. And then you rewrite the cosine square as 1 minus sine square, and then you have to do a u substitution. Let u be sine x. Again, there is a lot to take. I know without any example, it doesn't make too much sense right now. Just write this down. When we get to the first example, these things will make a lot more sense. All right, let's go to case 2. Case 2 is when the power of sine is odd. So case 1, cosine odd power. Case 2, sine is odd power. So the power of sine, we use m. M is equals to 2k plus 1. Again, you double up a number and then you add 1 to it. So m is always odd there. In this case, you factor out 1 sine. All right, and then you will have to use the fundamental identity. Sine square is equals to 1 minus cosine square. So the given problem, they have a sine raised to the odd power and then cosine raised to a big power dx. So first thing first, you factor out a sine, right? Do you see that there is a yellow underline? You factor out a sine. So we have the leftover, we have sine square times k. So basically we have 1 first power and then plus 2 times kth power. So that will be 2k plus 1. So the first power goes out to the underlying sine of x because you factor it out, right? So there is your first power, and then the rest, you have sine raised to the 2k. So you square the sine first, whatever that is, you raise that to the kth power. So that is 2 times k, which is equals to 2k, and then the cosine, you don't touch the cosine. So after the setup is done, you rewrite the sine square as 1 minus cosine square, and then you let u equals to cosine. All right, for the u substitution. Again, this is only the cookbook recipe. When we get to the first example, you match that example to case 2, it will make more sense after you solve maybe 1 to 2 problems. All right, and then case 3. So in case 1 and case 2, we already talked about cosine up power and sine up power, right? What if they are both even? So if they are both even, then you have to use the double angle identities. So either one of these identities will work. I know if you look up double angle identity, they will give you the 3 in white. So the one you see in blue, they manipulated a little bit. So for example, the first one you see on the left, you have sine square x equals to 1/2 times cosine 2x. So this came from the one on the bottom, cosine 2x equals to 1 minus 2 square sine x. So what they did is from the blue to the white, if you multiply both sides by 2, and then you swap the position of cosine and the sine, you will get back to the double angle formula. Same thing for the other two formulas. So this one is you will have to use double angle identity, but you have to express the double angle identity in blue, not the one in white. The white is what you had back in pre-calculus, but they would like to manipulate the problem. They would like to manipulate the identity a little bit because the integrand is all in sine raised to some power and cosine raised to some power again. So before I end this video, this is only a cookbook recipe. When you learn trigonometric integral, you have to write down the entire recipe first. And then you give yourself a problem, match that problem to one of the cases, and then use that instruction to integrate the trig integrals. It's a lot to take. It is what it is. This is what you have to learn in trigonometric integral. All right. So in the next video, I will give you example, and then I will show you how those examples match to each of those cases. All right. I will see you there. Signing out for now.